The campers are doing some background information on how varying the weight influences how the fidget spinner spins, and ultimately they're going to use this information to design their own fidget spinner with the goal of making it spin as long as possible. The NanoLab tour gave the kids an opportunity to see some of the nanofabrication techniques and the microscopes that we have here at Penn State. A couple of the campers got dressed up into the bunny suits and boots and masks, so they got an appreciation for how hard it is to work in that space. And they also got to see all of the different equipment.
The objective is to get them really familiar with concepts like surface tension or interfacial tension and surfactants, and how do these concepts play into their daily lives. Why is a water droplet spherical? Why do you use soap to wash the oil off your dirty dishes? And so we're trying to teach them the fundamental science behind that, and then also tie those concepts to the current research that we're actually doing in our labs here.
Yeah, so the big idea here is that the way we shape materials, in this case 3D printed plastic, can give different functions. So we're interested in building gliders, or we're interested in building parachutes that serve different functions that we'll test out in the hallway. And so shaping these materials in different ways, we can make lots of things out of plastic. And so we're trying to get plastic to float and fly, which is an unusual job for plastic. And so we'll see how that does in this activity.
In the computer lab, the kids were getting a feel for computational material science, where we use computers and mathematical algorithms to actually predict how things behave in the real world. And many times students don't get any exposure to that in high school science classes.
The other thing that we did in the camp today was to look at human technologies that involve light, matter. So we looked at, for example, just cell phones. Look at all these displays all over the place. The red, green, and blue LEDs. So pretty much like part of our daily life now, right? The other example we saw was optical fibers and fiber networks. And all of that internet fiber optic cable that's underneath the ocean, that's all a highway of light.
The goal is really to be able to inspire them through some hands-on activities, the science, and the potential opportunities in the future, to inspire them to be interested in science and engineering, to be able to pursue a career in such an area. So that's the hope. I think exposing them at this early age to something like that will hopefully demonstrate to them how things like courses that they're taking, like chemistry or physics, or maybe even math, how they're actually important, and people need to know those things to be able to improve our own society.
A major part of engineering is to be able to design and build new structures, and in classical education, kids often don't get a chance to do that, so we wanted to give them an opportunity here to come up with their own ideas, to try to build them, test them out, and then modify them if needed, just like a real engineer would.